Sometimes we just want to do a quick manipulation on our data, like what we have here, but more often we want to apply several of these functions that we've seen so far on our data. Like for example, here instead of calculating the average age of all the individuals, I would like to calculate the average age of only the people who are above 25, for example. So for that, I need to first use a function filter on my data set, and so that I keep only the rows where age is greater than 25. The issue though is that each of these functions don't affect the data frame directly. So instead it generates a new object, and if we don't store this new object, there's no way to use it again. So if I run this command, these two commands together, you'll see the average age doesn't change. So one solution is to store the result of my first operation by assigning the object to a name. Like for example, I'll call it small data filtered. So I'm creating a new object that is the data frame small data but filtered. And if I use this new object as the data for my summarize, then I get the new average age of only the people who are above 25. Doing so is actually essential for group by, the function that we left aside in the previous video, because group by groups rows based on some columns, so that the result of the other function are given by group. So on its own, it's not very useful. If I type the command group by small data gender, here I'm asking R to group the data frame small data by gender, but this command just gives me data frame that looks exactly like the original. So it looks like nothing happened, but actually internally something happened. And if I save this data frame by giving it a new name, small data groups, and then I summarize this new data set. If I run these two commands, now my summarize give me the average age for both the female and the male for both my groups. Now, what if I want to do a longer sequence of manipulation? Say I want to filter some data, then to create some new column using mutate, to group by a column, to group the data by a column, and to summarize the data by the group that I just created. To make it work in sequence, I would have to save the result of the filter command into a new data frame that I would use for my mutate column. I would save the results in a new data frame that I would use for the group by command, and I would need to save the result of the group by to, again, a new data frame that I would finally use for the summarize. Of course, there would be some extra things in the command to tell R which column I want to group by, which column I want to create, etc. So this would work, but you see that it starts to be a bit messy, and there's lots of extra steps. Like, we don't really care about data 2, data 3, data 4. Well, what we would like is to make the code much more readable, is to just tell R that we are using the data that we want R to filter it, then to mutate it, then to group by some column, and then to summarize. And that's where the pipe operator comes in. pipe is an operator whose symbol is a combination of a percentage sign, a greater than sign, and another percentage sign. And this operator is very useful. You place it in between two commands and it says to R, take what's on my left and make it the first argument of the function that's on my right or below me. So when we have a command with some data, then a pipe operator, then a function, the pipe will tell R to take the data which is on its left and to make it the first argument of the function, which is on its right. And here comes the beauty of what we've seen so far. Each of the 6 core dplyr functions was taking data as their first argument. So an alternative way to write a command with this function, like the filter function, would be to place a pipe just before the function, move the data out of the function, and place it to the left of the pipe. At first it doesn't seem of much use, just another way to write the command. But things becomes interesting when we have more than one function to apply to our data. Because with pipes, R interprets the command sequentially from left to right. So if we place a new pipe after our first command and say function mutate, for example, to its right, the first pipe says to R, take the data on my left, make it the first argument of filter. That's good. This is creating a new data frame with only the rows we want. And the second pipe is saying to R, take what's on my left. That is this new data frame, and make it the first argument of mutate. So it will add or modify a column to our new data sets directly. And we could continue. I could then add a pipe to tell R to group the resulting data and to calculate some summaries for each of these groups. So let's apply it to our data. Our data is called small data. Let's say we don't trust the age of Patricia, for example. So I would use the function filter to keep all the rows except for the row where name is equal to Patricia. This symbol is the one to say different. Then I want to create a new column, which would be the age next year. I want to give it a name though. We didn't do it last time, but here it's important because we want to use it. I want to use it for the summarize. Then I want to group my data by gender and to summarize by calculating the average of the new column that we created. And if I run it, it works well. Now, if you recall, the pipe says take what's on my left and make it the first argument of the next function on my right or below me. So instead of placing the function on the right of the pipe, we can also place it just below it, like that. And that's actually the way everybody writes such code when they have more than one or two functions to apply to their data. It is good practice because it makes the code very easy to read. So we can keep our code like that, but if we wanted, we could also save the result of this command to a new data frame, like that, or we could also simply continue the command with a new pipe and some other function. Because dplyr was built with pipes in mind, but the usefulness of pipes has become so clear recently that lots of new packages started to be built to work with pipes too. And do you remember, by the way, what was the first argument of the function ggplot? That's right, the data. So ggplot works with pipe too. Let's make one quick graph after the mutate. I'll make a simple box plot. Well, I don't need to indicate the data because the data is what is just above, and the pipe tells me that what's above is the is the first argument of ggplots. So I just need to indicate my variable x, which I'll choose gender, and my variable y, and I choose age 2 for y. And then I need to ask R to make a box plot. So I type the command geom boxplot. And here it is. The name pipe is not randomly chosen, by the way. Yeah, you could picture a sequence of piped commands as simply a long pipe in which we would pour data at the top. The data slides, functions are applied along the way, and at the end you obtain a new modified data frame or graph or something else, depending on of the last function in the stack of functions. More and more people are using pipes in their workflow. And as a result, when you look for help on internet, it's not uncommon to see responses to questions with a code that use pipes. And that is the other big reason to learn about it and dplyr right from the start. It's important because it will make it much easier for you to find the help that you need.